Before we continue, we need to understand that not all molecules are in one plane as they are written or drawn on paper. Pause the video now and draw methane, CH4. I expect you may have drawn it like this, but in reality it is a 3D molecule and should be visualised as such. Imagine now the central carbon atom surrounded by a sphere. We now need to position the 4 hydrogen atoms in such a way as to ensure that all the paired electrons in the covalent bonds are as far away from each other as possible. This is known as electron pair repulsion theory, as the electron pairs in both bonding and lone pairs repel one another. We will end up with a triangular based pyramid shape at the bottom, with a hydrogen at each corner and a 4th hydrogen coming out of the top. This shape with 4 bonding pairs is known as a tetrahedral molecule, with a bond angle of 109.5 degrees. You will probably have come across the ammonium ion, NH4. Pause the video now and try and draw the shape of this molecule. This NH4+ still has 4 bonding pairs around the central atom, and therefore will be another tetrahedral shape the same as methane. Let us now look at ammonia NH3. Pause the video and draw a dot cross diagram for this molecule. Here is the dot cross diagram. As you can see, there are 3 bonding pairs and 1 lone pair. The lone pair electrons will still repel the bonding electrons. In fact, the repulsion of lone pair electrons is stronger than that of bonding electrons. Consequently, the molecule will be based on a similar shape as before, only this time the lone pairs will repel the covalently bonded hydrogen atoms even more, creating a pyramidal molecule, with a bond angle reduced from 109.5 to 107 due to the extra repulsion of these lone pair electrons. Finally, let's look at water, H2O. Pause the video again and draw a dot cross diagram. Here is the dot cross diagram. You will see that there are now 2 bonding pair electrons and 2 lone pair electrons. The lone pair electrons will repel the bonding electrons even more than before, creating a V-shaped or bent molecule with a bond angle of 104 degrees. As you can see, all 3 of these molecules were based on 4 electron pairs, either bonding pairs or lone pairs. They were therefore all based on the original tetrahedral molecule. However, the bond angle changed due to the extra repulsion of the lone pair electrons.